Okay, we're going to look at the second page, numbers 5 through 8 on the chapter 6 review for pre-calc. So we're going to start with the information on the left. So remember, cosine and sine are the only ones that really have an amplitude. So we're going to put half there. So this is our A, just like we were doing before. This is our A. This is our B here, which is 3. The period has to do with the number in front of X there. Now notice X is over 4. So B is really 1 over 4. Oh, sorry about that. This is actually D. Still the vertical shift. I just called it B instead. That should be a D. Okay, so B is 1 over 4 in this case. 1 over 4. So if I take the typical period for cosine, which is 2 pi in radians, 2 pi in radians, and I divide it by B, because it's always the regular period over B. All right, so how do I get rid of that 1/4? Well, probably the easiest way is to multiply the top and bottom by 4, because then on top I get 8/4, and on bottom that just cancels out. So yeah, it becomes 8 over 1. This is 8 pi. Those cross off. And then I just get 8 pi over 1. The phase shift, just like before, is x over 4 plus pi over 2. I set it equal to 0. So if I minus pi over 2 to the other side, and then divide by 4. Well, when I divide, if it's x over 4, I want to do the opposite and I want to multiply by 4. So I'm going to multiply by 4. I get 4 over 2, which is 2 pi. And of course it's a negative. So 4 over 2 is 2 pi. All right. So we going to draw a graph. So vertical shift is 3. So 1, 2, 3. I'm actually going to go up to 4. This is 4, 3, 2. I may as well go down to 1 there. But it's going to hover around 3. And then from there, it's going to go up half. It's only going to go up half. So it's going to go up to 3.5 and down to 2.5. Okay. Then I'm going to kind of cut this off as workspace here. If I want to know where it starts, it always starts at where the phase shift is, which is negative 2 pi. It's going to end at whatever the phase shift is plus the period later. So that is going to be equal to 6 pi. So it's going to start at negative 2 pi and it's going to end at 6 pi. So again, don't get too hung up on where should I put 6 pi. Just make sure negative 2 pi is to the left of the y-axis. 6 pi, estimate about where that's going to be. Halfway in between. So I can go negative 2 plus 6 is 4 divided by 2. Halfway in between negative 2 and 6 is 2. Halfway in between negative 2 and pi is 0. So you can see my scale is anything but perfect. Maybe I can move that over just a little bit. Actually, that's pretty good. Just moving that one over made it a lot better. Okay, so halfway in between negative 2 and 2 pi is 0. But we are going to start at negative 2. We're going to end at 6. I want to draw my graph in the yellow rectangle. So I might even just get rid of some of this because I don't want to get confused. And my cosine graph, and it's a regular cosine graph, not negative. It's just a regular cosine graph, is going to fit in with between that circle. So it's going to start at the top, end at the top, bottom out halfway in between. So in that yellow rectangle, I'm going to start at the top, end at the top, halfway in between, it's going to bottom out. It'll cross about there, cross about there. And cosine is over, under, under, over. Okay? All right. Let's go on to number 6, which is cosecant. So most of our time with cosecant is really spent graphing this. 3 times the sine of x minus pi. So I know sine has an amplitude of 3, but we're talking about the amplitude of cosecant. So be careful. There is really no amplitude with cosecant because it's going to continue going up. Remember, it's going to look like this when you're done, except with arrows that you can actually read. Okay, you'll see it in just a minute. The vertical shift, nothing was added to the end, so there is also no vertical shift. The period, well, cosecant, which is related to sine, so we're kind of concentrating on that sine, is normally 360 or 2 pi. Well, if we're talking radians, I'm going to go 2 pi over b. And our b in this case is, again, there's nothing in front of x, so there's an implied 1. 2 pi over 1 is 2 pi. And the phase shift, sorry about that, the phase shift is I'm going to take x minus pi equal to 0, and we're going to solve. So I'm going to add pi to both sides, and that's it. This is, phase shift is pi. So remember, we start at the phase shift, and we add that, end that much later. So we start at pi, and we end at where the starting place plus 2 pi, which is 3 pi. So we're going to start here, that's a 1, end here. Okay, so I know there's no vertical shift, which that just means it's going to hover around 0. And yes, it's true that there's no amplitude, but we do have to consider the amplitude in our actual graph. The amplitude that is not an amplitude. How is that? 1, 2, 3. Okay. Because the first thing we're going to do is we're going to sketch that sine graph. So we're really still concentrating on this whole equation here. We want to try to graph that whole equation. So it's going to go down to -3, up to +3. We have kind of a midline here. We're going to start at pi. So I'll say, okay, let's just say that's about there. Let's say this is about 3 pi. I mean, that's not perfectly spaced, but in fact, you know, it's not great because if I put 2 pi in between, look at the difference between 1 pi and 2 pi. It looks a lot bigger. It's fine. As long as we can see the beginning is pi, the end is 3 pi, the middle is 2 pi. You can put those 2 notches in between. Remember, between 1 and 2 is 1.5. Between 2 and 3 is 2.5, or 5 pi over 2. Okay? So we are going to start here and end here. And again, if I want to get rid of some of the rest because I don't want to get confused, I'll get rid of this. And again, I'm still trying to graph this sine graph, but I'm going to draw it really lightly. So I'm going to try to draw it kind of lightly and maybe as a dot. So this is going to be a sine graph. Sine graph starts in the middle, ends in the middle. The middle is the middle. So this is my sine graph. All right. But we're doing cosecant. So this is the trick. The cosecant part is really easy. We just add asymptotes, and we add them where the graph crosses, I'll call it the midline, crosses midline. So what color should I make my asymptotes? I guess I'll maybe do them pink. So it's where the graph crosses the asymptote. So like here's an asymptote, here's an asymptote, and there's an asymptote. And then the actual graph is I'm just going to call them, well, I'll just say curves, I guess. It's like parabolas to tops. Let's say maxes and mins. Maxes and mins. Okay, so here and here. Okay, and we could continue on, but you know, we could put another one to the right, another one to the left. But that's cosecant. So most of your time with cosecant is spent graphing a sine graph and then adding on to the top and the bottom. Okay, so tan. The hard part about tan is figuring out or graphing the period and the phase shift. It's not necessarily hard to find them. Remember, amplitude for tan, there is none. And the reason is because this is the shape of the graph. It's going to keep going up and up and up. The vertical shift, there is none because there was nothing added or subtracted to the end. Here, we take a typical period for tan, which is pi, and we divide it by b. Well, our b is 2, so the period is pi over 2. A typical tan period would be pi, but it's always the typical period over b. And then the phase shift for all of them, take inside of parentheses, set it equal to 0, and solve it. So I end up with negative pi over 2. So just like before, I'm going to say, okay, I start at negative pi over 2. I end at negative pi over 2 plus pi over 2, which is 0. Okay, so what does that mean? Well, I'm going to redraw my graph here. You know, and again, the vertical shift is just here. Amplitude, well, there is kind of a slight, it goes up 1, down 1. We don't plot those, you don't need to plot those points. I just want to see the middle, so don't really even worry too much about going up 1, down 1. Mostly, you want to see the vertical shift, that there, in that case, it just hovers around 0. And then we're going to look at that it starts at negative pi over 2, and it ends at 0. And halfway in between is negative pi over 4. I think I'll just put those notches. I could figure out what they are, but I'm not going to. All right, but the thing is, what does that mean that it starts there and ends there? So I want to think what typically happens at 0 for the parent graph of tan. What typically happens? Well, I'm just going to make a little more room. You can look at the notes the hard copy of the notes if you need to see some of this too. But if you think about what a typical tan graph looks like, it's on 0. It's on 0. Well, so that's usually where it starts. It starts at the center. And then it would, if it starts at 0, it would typically end at pi. That's where the next cycle would be. Well, now instead, it's going to start here and end here, which means what normally happens at 0, this is what happens. So what's going to happen at our new 0, it's going to be a tan graph. Okay? And it would occur at the end as well. It would occur at the end as well. It would occur at pi over 2 again. But so instead of the graph occurring at 0 like it normally would, it occurs at the new start, which is negative pi over 2. The new graph appears at the end again. The new cycle appears pi over 2 later. Well, then halfway in between, remember, is the asymptotes. Okay, there's an asymptote over here, but it kind of ran over room. And you can say here as well. But for sure, we want to see an asymptote in negative pi over 4, kind of halfway in between. So just if we were doing cotan, think where does cotan, what typically happens at 0 for cotan? What typically happens there is an asymptote. So for cotan, there's typically an asymptote at 0. And then there's an asymptote at 180 again. What happens halfway in between? The cotan graph. So just talking a little bit about tan and cotan. All right, and then one more on this video, just to end this page, we're writing an equation. So this is what our typical equation looks like. We're going to put plus or minus because we don't know if it's positive or negative. It can be sine or cosine. In this case, we're supposed to write cosine. So I guess we'll just go ahead and do cosine here. And then it is b x minus c plus d, okay? And we basically just plug it in. So I'm going to put the plus minus, I'm going to put the cosine, do the x, and we're going to fill in and simplify. So the amplitude is 5, so that amplitude just goes right there. I'm going to wait with the period. The phase shift is pi, so I'm just going to put that here. I'm just going to put that there. And the vertical shift, this d, is -1. So we actually plug the phase shift in. So our phase shift is c. Our amplitude is A, vertical shift is D. The one thing we have to calculate is B, because B is 2 pi or 360 divided by the period. Remember before we found the period by going 2 pi over B? Well, now we're doing the opposite. Well, the period in this case is 2 pi over 3. So to get rid of that, I'm just going to start by multiplying by 3, right? If I do that top and bottom by 3, then I get 2 times 3 is 6 over 2 pi. Pi's cross off, and we're left with 3. So B is 2 pi over the period. So that's our B. That's pretty much it. So most of our work is spent trying to find this. Now, if I want to just clean that up a little bit, I'm going to keep the plus minus. My pen's giving out. I'm going to keep the plus minus, and then I'm just going to clean it up. Cosine 3 x minus pi. Really, the only thing I need to clean up here is instead of plus -1, -1. All right, and that is the graph. Now, again, we put plus minus because it doesn't tell us when we write the equation if it's a positive cosine or a negative cosine. I think in the answer key, it says it doesn't have plus minus in front, so it's not a huge deal, but really we should put plus minus because we don't know for sure which one it is. Okay, so I'll finish the last page in the next video.